Welcome to the last lecture on morphine part 3rd. We will touch upon the last points of this lecture. First is the point of attachment of CH2 and methyl or the side chain, position of double bond, structure of morphine final, and the reactions of morphine with the final structure which we have determined. Here we will study in this lecture the point of attachment. As you can see here, this CH2 and methyl, this chain is attached at this position. We will determine this position at which carbon it is attached, the position of the double bond, and the structure of morphine and the reactions of morphine. Morphine forms monobromo derivative with bromine and monosodium salt with NaOH. It possesses only one benzenoid nucleus. These two reactions, which reveals that monobromo derivative with bromine and monosodium salt with NaOH, it possesses only one benzenoid structure. As ethene is formed during Hofmann exhaustive methylation of kudimethines and dimethylaminoethanol is formed, a CH2 and methyl change must be present in morphine. So the partial structure of, you can see the morphol with here 1, 2, 3 at position 3 OH, at 6 position OH, this is phenolic OH, this is secondary alcoholic group, ether linkage at C4 C5. This up till now we have determined this structure. Now there is one side chain also which is formed during Hofmann's exhaustive methylation. This is N-methyl ethanol. This chain plus one double bond is also formed. So this one double bond. So we have to determine the position of these two one double bonds and the chain. The point of attachment of CH2 and methyl group. This is done by the following series of reactions. Codeine on chromic acid oxidation, it forms hydroxycodeine. That means one hydroxy group is introduced here, which on Hofmann's degradation it converts into ketocodimethine, which on reaction with heating with acetic anhydride it forms methoxydiacetoxyphenanthrene. This methoxydiacetoxyphenanthrene on further oxidation it converts into methoxyacetoxyphenanthraquinone. That means a double bond again is introduced in the quinone structure is introduced on further oxidation. So you can see the series of reaction. Codeine on oxidation with chromic acid gives some hydroxycodeine along with codenone. Then the hydroxycodeine on Hofmann degradation it converts into ketocodimethine, which on heating with acidic anhydride it affords methoxydiacetoxyphenanthrene, which on further oxidation gives a quinone with a loss of acetoxy group. The inferences drawn from this series of reaction, as you can see here, loss of acetyl group indicates that one of the two acetyl group in methoxydiacetoxyphenanthrene must be present at position 9 or 10. This position 1, 2, 3, 4, 5, 6, 7, 8, 9 or 10. This means that out of two, one of the acetoxy group is present as position 9 or 10. Since this acetoxyl group is introduced during the aromatization with acetic anhydride, the ketonic group in ketomethine must be present at position 9 or 10. This ketonic group must be positioned in either of these two positions, the 9 or 10. As the secondary OH group of hydroxycodone is converted into ketonic group during Hofmann's degradation method, double bond must be introduced between C9 and C10 during fission of the nitrogen ring, and thus nitrogen must be linked at C9 or C10. As you can here see, this codimethine on chromic acid, it is converted into hydroxycodone. Here one OH is introduced here with oxidation, and this ring has been detached. Now on Hofmann's degradation, again you can see Hofmann's degradation, this bond breaks and a double bond is introduced here. This ring has been converting it to hydroxycodimethine. This hydroxycodimethine, it converts into, isomerizes into ketocodimethine. As you can see, this converts into a double bond, a convert ketomethine, which on treatment with acetic anhydride, as you can see, on acidic anhydride, this codimethine on treatment with acetic anhydride, it converts into acetyl derivative here also and here also at position 6. So on further oxidation, this converts into a methoxy group, and here it is acetoxy group, and this converts into a quinone. This is known as hydroxyquinone. So this is the series of reactions which we have studied, and as you can see here, there is one very important inference or statement given by the two scientists Gouland and Robinson in the year 1923 regarding the constitution of morphine. The formation of the phenanthrene derivative can take place for structural reasons unless the ethamine chain is displaced. Since the nitrogen end is shown at position 9, the carbon end of this chain must be at angular positions according to this statement of Gouland and Robinson. As you can see here, as this is the position 1, 2, 3, 4, 5, 6, 7, 8, 9. Position is the position which we have stated earlier also, it is at position 9. So the carbon end of this chain must be at position, this angular position 13 or 14. So position must be at either 13 or 14. So this is 9, 10, 11, 9, 10, 11, 12, 13, 14. Position 13 is selected on the basis of the reactions of this compound of which belongs to thibane, which also belongs to opium alkaloid. This thibane converts into thebanine. So on the basis of this, the inference drawn is the position 13. We need not to go into the detail of this. We only have to convert that. We only have to write that this is position 13 is selected on the basis of thibane and thebanine. So this is position 13. Angular position 13 has been selected for the attachment of this ring. So the partial structure of morphine is given, as you can see. This ring, this N-methyl ring has been connected at position 9 and 13. Now only one thing is left, the position of double bond is not been stated. So position of double bond is next step is the position of double bond. Codeine on treatment with phosphorus pentachloride yield alpha chlorocodide, which on reaction with aqueous acetic acid it affords a mixture of codeine, isocodine, pseudocodine and allosudocodine. The first two gave the same ketone. These codeine and isocodine, they both gave the same ketone, codenone on oxidation, which differing only in the position of OH group at position 6. So the only difference between these two isomers is at position 6, here at position 6. The later two gave the same ketone again, suggesting that they differ in the position of OH at C8. So the at C8 that they differ at the position of OH group. So the double bond is present between C7 and C8 on the basis of these experimental facts. So the position of the double bond has been shown here, C7 C8, here also C7 C8. So the structure of morphine, as you can see, the phenolic group at position 3, this is phenanthrene nucleus, ether linkage between C4 and C5, there is one hydroxyl group at position C6, double bond is present between C7 and C8, and the nitrogen chain is joined as at position 9 and 13. So this is the structure of codeine. The only difference is the position or the presence of methoxy group instead of phenolic group. So from this structure of morphine, all the reactions can be satisfactorily explained. As you can see, morphine on treatment with dimethyl sulfate, it converts into codeine. As you can see, the methoxy derivative has been formed. Then on Hoffman's degradation, it converts into alpha codeine methine, and the shifting of double bond takes place on heating. It isomerizes into beta codeine methine. Then on beta codeine methine, on treatment with methyl iodide in the presence of alkali, it converts into this methoxy group, ether linkage OH, and this one here the breakage of takes place from this position, angular methyl group. Next, on heating, it converts into this compound, which again heating with this acetic anhydride, it converts into this one, and which on treatment with HBr and sodium ethanol, it converts into morphol. So all these reactions can be explained with the help of this structure which of morphine which has been given. So the correct structure of morphine is this one, with again the position of phenolic group is at position 3rd, ether linkage at position 4th and 5th, hydroxyl group, secondary alcoholic group at position 6th, and the position of N-methyl and this chain is at this carbon atoms 13 and 9, and all these can be explained. Double bond between 7 and 8. So this is about the structure of morphine. The synthesis is very in detail. I have not dealt in my lecture. If you want to deal with the synthesis, you can see from the reference book.